Thanks a lot for the introduction. So IP is really ecosystem. Now in 20 nanometer, right? So 22 nanometer, 190 IPs on one SoC is very normal. It's with the IP, basically verification IP is part of the ecosystem. You have to verify the system, right? So we live in really interesting time. The gadgets are showing up left and right. The environment is changing, and our customers need more and more. And we are touching their lives as we are with the electrical engineering, right? So with this and the space, the speed of it, it comes challenges. Just look at the expanding variety of DRAM interfaces. From 93 to 2000, we just got from SDRAM to DDR. Now, from 2011 to 2014, just look at the right side, the specialization of the interfaces, the number of varieties that we got. With this, the in-house solutions doesn't make sense anymore. You can't come up and give up and basically keep up with these changes. So, and it is not just for DRAM, for all the family of protocols. This is for PCI Express, ARM, AMBA, USB, HDMI. And this is just last 6 years, 7 years. So many variation of interfaces are coming up. And the key is this specialization. So Cadence has predicted this and provided the broadest catalog of verification IPs for functional verification. So from the family of interface VIPs, on-chip interface VIPs like AMBA family, and PCI Express off-chip the VIP interfaces, we have the entire family of those products. The another category is memory models. We have over 6,000 memory models that is widely used. In addition to that one, we have accelerated VIP and some productivity tools that we see more of it as we go along. So when you get one of these, look at one of these protocols, like PCI Express, is massive amount of information. The protocols is like now over 1,000 pages, right? So you have to model the protocol. You have to have the coverage model. It is more than just like a BFM as old times. Now you need the full spectrum of the verification. So you need the verification plan. You need the proper checking. And this is what Cadence provides. So basically, you're going to have an optimized core, which is independent of this, the methodology. You can use it with any methodology. And for different configuration. System Verilog UVM is supported. The examples come with the install come with the examples, very useful, and is all basically a standard UVM system Verilog. In addition to that one, E interface is available. If your language of choice is E, is provided. So basically, it's all about freedom of your methodology, to your language. Whatever it is, we supported it. And that's basically the rationale behind it. So it's multi-language test bench environment for the simulation core. And as far as the core is designed that it can be used for acceleration on emulation boxes. So that's very important too. So it works on various simulators, VCS, Cuesta, Incisive, and it has been used with many customers. So over 500 customers have used Cadence verification IPs. And it is the acronym, a smart choice, because it has the capability for a SoC level verification. It's support all kind of memory models, and we try and strive always to come up as the first one to come up with the verification IP. Is multi-language, multi-simulator. The core is designed to work with any simulator independently and get the same result with either of them. And it has very advanced productivity tools that we are going to see a little bit more of it. let's look at this ARM AMBA VIP family. We support all the AMBA family VIP, basically interfaces like CHI, ACE, XI4, XI3. Its maturity, it has been used in many projects, and basically it has compliance method, which is very helpful for verification engineers. Imagine you got this project and you have to start writing all the tests yourself. Rather than you have a set of tests, you can immediately start running it and get compliance verification that you want. So it's all about basically productivity. You can get this thing, get it and start it, run it immediately and get a result. And basically, in addition to that one, you got these protocol checks, and you can do it for formal, you can do it simulation, and even with the acceleration. So it's all platform is covered. Similarly, for PCI Express VIP, which we constantly come up, we were first introduced the verification IP, and now we have the spec event we recently announced for a 4.0. And it is advanced verification IP. It supports the entire spec, and already has been used with some customers. It has the triple check again. So basically, you get the verification, the specification, and you have to figure it out what area it needs to be verified. But this is all pre-verified, done. All the tests are provided, coverage models are provided, so can get you started immediately. Memory model, this is like de facto standard memory models that everybody is using. Whoever is, has been in the industry, they know the Denali memory models and now Cadence memory model. They have been using it for quite a while. It's more than 6,000 models, and across all different kind of vendors, we support all the memory models. So basically, the verification of these complex protocols, it requires more than just simple BFM. You need really productivity tools like this PureView. Instead of configuring it and with the manually and trying to figure it out, did I do it right or wrong? So we provide this graphical user interface that you simply select the functionality that your device is going to support. And if there are inconsistency, it simply is going to, without even getting to simulation, it's going to point it out. This could really save you a lot of time, rather than you pick something wrong and go on with it for a long time. And now, even if you're interested in class-based UVM, it also dump system Verilog class-based UVM configuration file out of PureView. This triple check, which is one of my favorite, is basically when you look at the verification, we are all metric-driven verification. I need to verify this. When I'm going to be done, right? So the whole question is, when I'm going to be done, did I run enough stimulus or not, right? So you never know unless you have a target in mind, right? You have a verification plan, you have your functional spec, and say, hey, I'm going to verify these items, and you have a coverage model. They say, yes, I ran the stimulus, I hit number 1, I hit number 2, I hit number 3, right? So that's the idea. So this is the beauty of this triple check. It comes with the verification plan. So when you look at it, you say, oh, I'm doing the PCI Express, this part of a spec, I completely verified it. And this is the coverage model associated with it. And then it comes with the functional coverage and the test suite. The test suite, you directly run it. And a lot happens that you get false failure, right? Because your DUT doesn't support the specific feature. But since we are using this PureView as a reference point, so basically if that feature is not supported, we even don't use those tests. We never get there. So basically, the PureView forces that the DUT and the verification environment completely match. So you will not get the false failure. So use that one, you hook up the VIP, and basically you complete your verification cycle from start to end. So this is what you get as a triple check. You get the test suite, you get the verification plan, and the coverage model. And this hits like 100% of the coverage model with those set of tests that you have triple check. Okay, now let's look at another verification IP, which is Cadence Interconnect Validator. For those of you guys doing the ARM subsystems, this is a very typical environment that you have multiple ARM cores, and they are connected to the interconnect fabric, and they're communicating with DMC or DDR memory or any of the slaves, right? So to verify that, basically, you're going to obviously replace the piece of it with verification IP. And this piece of verification IP is going to communicate the type of transaction that is going through to this interconnect validator. And that one is going to track it, the initiating transactions. So let's say you have a read burst, get started. It's supposed to go to that slave back there. Okay, so it's going to make sure, okay, this one gets started and arrive there. And if there are some transaction getting lost, or there are going to wrong the slave, is going to basically find that one. So it's a high-level scoreboard for the entire interconnect fabric, which is very, very helpful. It saves you a lot of time. So you can use this interconnect validator for a non-coherent environment. So it handles all different kind of splitting, upsizing, downsizing, and support independent address forwarding mechanism. Or you can use in the cache coherent environment where you have snoops and you have DVM, barrier, all kind of transaction. You understand those. For those of you guys who are doing the ARM verification, this is essential. Okay, this is another very powerful tool, and this is going to, basically what it does is really automate the functional verification. So it gets some basic information through this XML file or Excel, and out of that one, when you feed it to Interconnect Workbench, it's going to dump System Verilog UVM verification environment for you, which is basically is editable and you can use it. That environment, you can use it as it is and run your functional test. And when you're done with the functional verification, you can look at the performance analysis. So the two functionality that it does. So let me go to the performance analysis part. So when you have the interconnect fabric, that would be bottleneck of your system, right? But you need to find out how your transactions, how your interconnect fabric reacts versus the contention in this transaction with the configuration that you have and the arbitration. So what this one is going to do is going to show you the latency, the bandwidths, and the details, why it's taking so long, why it's so fast, why it's so slow. So this is essentially would be your performance cockpit. It provides you all the information you want for the performance. Okay, another great feature of verification IPs of Cadence is they're acceleratable. And this is a very important differentiator where you can, in a system that you are using emulator, so instead of using the ARM core exactly and writing a lot of tests for it, you can use the same environment you had with verification IP, do some changes, and put the accelerated VIP on the Palladium. And this allows you to run a lot more tests and it's a lot more faster because it's running on the hardware box. In addition to that one, we have Assertion-based VIP, which you can use it for formal verification with the IEV tool, or you can use it for simulation. And the advantage of this one is basically you do not need to provide the stimulus. The stimulus is provided by the tool mathematically proves these assertions versus your design. So these are pre-validated constraint and assertion are provided and can help you to verify. So we have for AXI and OCP. This is an example of AXI to OCP bridge that you can just hook up your AXI ABVIP and the OCP one and start your verification. All right, so let me summarize. So basically, we got like 69% of the market segment. We are the market leader in the verification IP. We have worldwide more than 500 customers, and number of thousands of design have used Cadence VIP for verification. So please feel free to let us know if you have any verification needs for verification IP. Thanks a lot, guys.